Okay, review exercise 17 from Unit 3, continuous probability. A company is manufacturing a part which has a mean length of 12 centimeters and a standard deviation of 0.003 centimeters. Product specifications are 12 centimeters plus or minus 0.01 centimeters. What proportion of individual parts are within specifications? What proportion are under the lower specification limit? 90% of the parts are below what length? Now that doesn't have anything to do with taking samples. Now, from below, take samples of size 10. Describe the distribution of the sample means when you take samples of size 10. What proportion of sample means are in the product specification? What proportion of sample means are in the product specification? And what interval centered at the population mean contains 95% of all the sample means? Okay, see if you can work this out. Press pause now. Okay, so the first three questions are just a normal probability questions, probability and inverse probability questions. The last three are dealing still normal probability, but dealing with a sampling distribution. So the first three questions are about individuals. The last three are about X-bar values or sample means. Here are the answers. Let's work them out. So what proportion are within specifications? Well, let's work out what those specification limits are. 12 minus 0.01 is 11.99, and 12 plus 0.01 is 12.99. So what we want is a normal CDF, right here, the first one, from 11.99 to 12.01, a mean of 12 and a standard deviation of 0.003. That's 0.99914, etc. So about 99.914%, or in other words, about 9 times out of every 10,000, or about 86 times out of every 100,000 times, it will fall out of the specifications. They'll make a bad part. What proportion are under this lower spec limit? Okay, so 1 minus this 99.914% is how much are outside, but how much are on the lower side? Well, that's going to be normal CDF. Well, the parts probably can't have a length less than 0, so we're going to start at 0 and go to 11.99, which is the lower spec limit, and then with a mean of 12 and a standard deviation of 0.003. Instead of 0, you could use m minus 10s in place of that. Or negative infinity would make sense, but you can't really put in negative infinity. In this case, a negative part length doesn't even make sense. So 0 is a good choice there. And notice it starts with a 4, so we look over here and see e negative 4. That means times 10 to the negative 4. Move this 4 places to the left, we get 0.3 zeros and then a 4, or in percent form, that's 0.043%. 90% of the parts are below what rate? That's below what length? That is an inverse norm problem. So this is inverse norm of 0.9, 12, and then that's the mean, and the standard deviation is 0.03, and that gives us about 12.004. Okay, so 90% are below that length. Now that part there had nothing to do with samples. That's just individuals, which are normally distributed. That does assume that they're normally distributed, which I probably should have told you. So let me make sure I put that in the problem. Okay, so to use the normal CDF or normal inverse norm, we must assume that those individuals are normally distributed. A lot of times parts actually are normally distributed. It's something we could check with a normal probability plot, but to do what I just did, we do need to assume that. So let's make sure that's part of the actual problem, which it is now. Now, take samples of size 10, describe the distribution of sample means. Since the distribution of individual measurements is normal, the distribution of sample means is exactly normal regardless of the sample size. So certainly with the sample size 10, we're fine. The sampling distribution has the same mean, which is 12 centimeters, but it has a smaller standard deviation, which is a standard deviation of the individuals divided by the square root of the sample size, which is what I did here, 0.003 divided by the square root of 10, and that gives us our smaller standard deviation there. So, what proportion of sample means are within the product specification? We're talking about between, remember, 11.99 and 12.01. So it's like this first problem, but now it's exactly the same, except instead of putting 0.003 here for the standard deviation, we put 0.003 divided by the square root of 10 there. And notice that's 1. So as far as the calculator can go, that's everything's there. Okay? Which is at least to, several decimal places more than I have indicated here. It's 100%, 100.000% at least. So to the limits of the calculator, that's 1. In theory, it's not. There's some very small probability it's outside of that, but it doesn't show up in the digits that are in the calculator. What interval centered at the population mean contains 95% of the sample means? All right, now think about this a minute. If 95% is in the center, that leaves 5% on both 5% that's not covered. Okay, that 5% is divided evenly between the two tails. So one tail on the left has 0.025%, and the other tail has 0.025%. So if we found the boundary of that left tail, there'll be 0.025 to the left. So that's an inverse norm of 0.025. The mean is 12. We use the standard deviation of the x bars, 0.003 divided by square root of 10, because we're talking about distribution of sample means here, and that turns out to be 11.998. Okay, and that's supposed to be here. Let's fix that. Okay, that's the lower part of our interval. Now, 95% again, that leaves 0.025 to the left of that interval, and then 95% in the interval. So the right boundary of the 95% interval is going to actually have 95% plus this 2.5%, or 0.975 to the left of it. Or another way to see that is it's going to have 0.025 to the right of it. 1 minus 0.025 is another way to get to 0.975. So 0.97, either way, 0.975 is the probability to the left of this right interval. And so then we give it the mean, the standard deviation of the x bar values, the standard error of the mean, 0.003 divided by square root of 10. And this gives us the x value for the right, the x bar value for the right. So x bar is between 11.9981 and 12.0019 95% of the time. Okay, a couple comments before I go on. These 17 exercises, at least at the point when I'm recording them, are extremely similar to the ones on the practice test and exam for my class. There are going to be following this 2 more review videos, which are me working a practice test from an earlier semester, where I work multiple problems in each video. Finally, I want to say that after this, there is some supplemental material on the videos, and all of these videos start with the word calculus as the first word of the title in this playlist. These videos assume that the viewer has studied at least some calculus. These are for enrichment for those students who have studied both calculus and statistics, but they are not required for a student just studying statistics at the level of this course. So they are not required and are strictly optional. They're only there if you just know some calculus and you want to study this a little bit more. So you feel free to ignore the rest of the videos in this playlist from my Probability and Statistics 1 class.